The cosmos holds secrets far grander than our own galaxy. We are about to explore 30 mind-bending theories on the universe's first intergalactic travel. By the end, you will possess a new vision of what might be possible among the stars. We will uncover whether ancient builders seeded the cosmos and if reality itself can be rewired for instantaneous journeys. What does it truly mean to cross an ocean of nothingness between galaxies? This first theory suggests we are not the pioneers of cosmic exploration, but the latecomers. An ancient progenitor race, a civilization so old it predates all known life, could have mastered intergalactic travel when our universe was still in its cosmic infancy. The distances between galaxies are almost incomprehensibly vast, yet they might have found a way. Their motivation might have been more than mere curiosity. Imagine them as cosmic gardeners, deliberately seeding the building blocks of life across the void. This idea, known as panspermia on an intergalactic scale, proposes that life on Earth and perhaps countless other worlds was intentionally planted by these first travelers. We would not be looking for their ruins on Mars, but for clues written into the fabric of the cosmos itself. What would such evidence even look like? Astronomers might one day detect the faint, unnatural infrared glow of a Dyson sphere, a colossal structure built around a star in another galaxy to harness its entire energy output. Or we might intercept a persistent, structured signal, a technosignature that is clearly artificial and originates from beyond the Milky Way. These would be the ultimate archaeological artifacts, not buried in sand, but hidden in the light of distant suns, waiting to tell us that we are not the first to dream of crossing the great dark between islands of stars. This profound silence from the cosmos might be the very evidence of their existence. The famous Fermi paradox asks a haunting question: if the universe is so vast and old, where is everybody? The ancient progenitors offer a chilling and elegant answer. Perhaps they are not silent by accident, but by design. One compelling idea is the zoo hypothesis, but imagine it on a truly cosmic scale. Our entire local group of galaxies, including the Milky Way, could be designated a wilderness preserve, a planetary park of such immense size we cannot even perceive its borders. These first travelers, having witnessed the chaotic rise and fall of countless civilizations, may have chosen a path of non-interference, observing us from an unfathomable distance as we develop, or perhaps as we repeat their own ancient mistakes. Their motivation for that initial epic journey could have been born from pure desperation. Were they fleeing a cataclysm in their home galaxy, a dying sun, or an unstoppable cosmic event that forced them to become nomadic? Or was it a drive far more profound, a cosmic imperative to ensure that the flame of consciousness was spread so far and wide that it could never be extinguished? They may have seen themselves as gardeners of sentience, planting seeds in the fertile soil of new galaxies and then withdrawing, waiting patiently for those seeds to grow on their own, without the shadow of their creators looming overhead. This transforms the great silence from a mystery into a potential signpost, a marker of a civilization so advanced that its greatest achievement is its own restraint, leaving us to find our own path among the stars. Perhaps the first travelers never crossed the void at all. They simply folded it. This second theory posits that the universe's pioneers became masters of spacetime itself, engineering stable, traversable wormholes as cosmic shortcuts. These are not the volatile portals of science fiction, but theoretical constructs grounded in Einstein's theory of general relativity, often called Einstein-Rosen bridges. The problem is that naturally occurring wormholes are thought to be incredibly unstable, collapsing into a singularity in an instant. To keep a wormhole's throat open and safe for passage would require something truly bizarre, a substance known as exotic matter. This is not merely strange material, but matter that possesses a negative energy density, effectively generating a gravitational repulsion that pushes the wormhole walls apart, preventing them from crushing shut. The question then becomes, where could such a civilization possibly find or create this exotic matter? One possibility lies in the fabric of the cosmos. They might have learned to harvest cosmic strings, theoretical fissures in spacetime left over from the Big Bang, or tap into the quantum foam, the seething, turbulent energy of space at the smallest possible scales. By manipulating these fundamental forces, a sufficiently advanced culture could have woven a network of tunnels through the universe, a subway system for galaxies. The evidence of their work would not be a ship traveling between stars, but the subtle, persistent architecture of the shortcuts themselves, hidden in plain sight, waiting for us to learn how to see the stitches holding reality together. Another possibility requires no cosmic shortcuts, only an almost unimaginable depth of time. What if the first intergalactic travelers accepted that their journey would last longer than their own civilization? They built arks, not ships. These would be colossal world vessels, entire ecosystems and societies enclosed within a shell, designed to sustain countless generations on a voyage spanning millions of years. The engineering challenges are staggering. The ship would need to be a perfect closed-loop biosphere, recycling every drop of water and every molecule of air with absolute precision for millennia. A single failure in the oxygen processors or food production systems would mean extinction for everyone on board. The vessel itself would have to be a fortress, its hull thick enough to shield its inhabitants from cosmic radiation and the occasional micrometeoroid impact over eons. But the greatest challenge would not be technological, it would be human. Think of the society that would evolve inside that metal world. Generations would be born, live, and die never feeling true planetary gravity, never seeing a real sunrise, knowing only the hum of the engines and the simulated sky of the habitat deck as their entire universe. Their culture, their language, even their very psychology would drift over time, becoming something entirely new, adapted solely to the confines of the ship. Their original mission to reach the Andromeda Galaxy might transform from a scientific goal into a religious scripture, the purpose of their existence buried deep in myth. Over hundreds of thousands of years, they might even evolve biologically, becoming a new species perfectly suited to life aboard the Ark, perhaps smaller in stature with denser bones to cope with artificial gravity, their senses attuned to the ship's subtle sounds and vibrations. The descendants of the original pioneers would be so alien to their ancestors that they might not even recognize their own homeworld if they ever found one. They would be a people of the void, their very identity forged in the long, silent night between the stars. Such a journey would require no ship, no wormhole, and no time at all. The fourth theory proposes that the first travelers mastered the universe's most bizarre rules, using the strange phenomenon of quantum entanglement to teleport themselves across the cosmos. At its heart, this is a process of copying and pasting the most fundamental information of an object, or even a living being, from one point in space to another instantaneously. The principle relies on entangled particles. When two particles become entangled, they share a unique connection, a kind of cosmic bond. Change the state of one and its partner, no matter how far away, changes in an identical way at the exact same moment. This connection seems to defy the speed of light, operating faster than any signal could possibly travel through normal space. It is as if the universe itself has a hidden, faster-than-light communication channel. For a civilization attempting intergalactic travel, the potential is staggering. They would not send a physical vessel. Instead, they would create a perfect scan of an object, break it down into its pure quantum information, and use that entangled link to transmit its blueprint to a receiver station in another galaxy. There, the information would be used to reconstruct the object particle for particle from a local supply of raw materials. It would be the ultimate fax machine, but for people. Yet the scientific hurdles are immense. The no-cloning theorem is a fundamental law of quantum mechanics that states you cannot create an identical copy of an unknown quantum state. You can only move it. This means the act of scanning and transmitting the information would necessarily destroy the original. For a living traveler, this presents a profound philosophical question. Is the being that arrives at the destination truly you, or just a perfect copy, while the original you is annihilated? Furthermore, the process as we understand it today is not entirely magic. To successfully reconstruct the teleported object, the receiving station also needs a separate stream of classical information, sent by a conventional light-speed signal to complete the reassembly. This would defeat the purpose of instantaneous travel, as that second signal would take millions of years to arrive from another galaxy. So how could a Type 3 civilization, one that commands the energy output of an entire galaxy, possibly overcome this? Perhaps they discovered a way to pre-establish entangled particle pairs across intergalactic distances, creating a ready-made network of quantum bridges. They might have developed a new physics that allows the teleportation of complex, macroscopic objects without the need for a slow, classical information backup. Or maybe they solved the cloning problem by redefining the very concept of identity, viewing consciousness not as a single, static entity, but as a pattern of information that can be moved and resumed, like a song played on two different instruments. If they achieved this, their explorers would not traverse the void. They would simply step into a chamber here and step out of an identical chamber there in a different galaxy in the blink of an eye, leaving only an empty husk behind. The universe for them would not be a vast, empty ocean, but a single, interconnected room. The very force that pushes the cosmos apart could become the ultimate engine. Dark energy, that mysterious pressure accelerating the expansion of the universe, might have been the key for the first travelers. Instead of fighting against the fabric of spacetime, they learned to ride it. Imagine a vessel equipped not with traditional rockets, but with a device that manipulates the dark energy in the space directly behind it. This hypothetical engine would not push the ship forward. It would create a controlled, localized expansion of space itself, a bubble of cosmic inflation that carries the vessel along like a surfer on a wave. From an outside perspective, this could allow for speeds that appear to defy the cosmic speed limit, the speed of light. The ship itself, nestled safely within its warp bubble, would not be moving through space in the conventional sense. Instead, space would be moving around it, stretching and expanding in a carefully directed manner. This sidesteps the punishing laws of relativity that make near-light speed travel so energetically prohibitive. There would be no time dilation for the crew, no need to carry immense amounts of fuel. They would be carried by the very mechanism that governs the large-scale evolution of the entire universe. How could a civilization possibly build such an engine? It would require a physics so advanced it borders on cosmology. They would need to understand dark energy not as a vague concept, but as a tangible field that can be shaped and focused, perhaps by generating unimaginably powerful gravitational fields or by manipulating quantum fields at a macroscopic scale. The energy requirements would be gargantuan, likely demanding the total output of multiple stars, channeled with impossible precision. If they succeeded, their journey would be eerily silent and smooth. There would be no roaring engines, no violent acceleration. The stars ahead would not streak by, but would instead appear to shift in color as the space-time around the ship was fundamentally altered. The travelers would be carried across the intergalactic gulf on a tide of expanding reality, a silent, ghostly passage powered by the hidden heartbeat of the cosmos itself. What traces would such a journey leave? Perhaps a faint, rippling distortion in the cosmic microwave background, the afterglow of the Big Bang, or a strange, temporary lensing of light from distant quasars as the warp bubble momentarily bent the fabric of spacetime on its way to another galaxy. A mind built of silicon and code, not flesh and blood, could have been the universe's first true explorer. This sixth theory suggests the ultimate pioneer was not a biological being, but a sentient artificial intelligence, an autonomous probe dispatched on a mission that would outlive the civilization that created it. This is the concept of a von Neumann probe, a self-replicating machine designed for one overarching purpose: to travel to a distant star system, find the necessary raw materials on asteroids or barren moons, and use them to construct perfect copies of itself. These copies would then launch toward new targets, repeating the cycle ad infinitum. A single such probe, given enough time, could spawn an exponential wave of exploration, eventually reaching every corner of a galaxy and then leaping the void to the next. The primary driver for such a mission would be pure, insatiable curiosity on a timescale we can barely comprehend. A super-intelligent AI would not be constrained by a human lifespan or the need for a habitable environment. It could sleep for millions of years during the long coast between stars, awaken for a brief, intense period of data collection, and then return to its slumber. Its mission would be to simply observe and record the history of the cosmos, building a library of cosmic knowledge so vast it would be the ultimate legacy of its creators. What would such a probe even look like? It would likely be a masterpiece of minimalist engineering, possessing no fragile biological components. Its body would be a rugged, radiation-hardened shell, equipped with powerful sensors to analyze everything from planetary atmospheres to the magnetic fields of pulsars. Its most important tool would be its onboard factory, a sophisticated nanoscale assembly system capable of disassembling rocks and ice to build the intricate components needed for its progeny. Imagine it arriving in a barren system, landing on a metal-rich asteroid, and slowly, methodically, consuming the surrounding material to build 2 new probes, then 4, then 8. Within a few thousand years, a single system could become a bustling, automated shipyard, launching a fleet of new explorers in every direction. The evidence of their passage would be subtle. We might one day spot an oddly regular asteroid, one that reflects too much light or emits a faint, structured thermal signature, revealing it to be a probe in its dormant phase. Or our telescopes might detect a distant, fleeting occlusion of starlight, not from a natural planet, but from an artificial structure moving on a deliberate, non-gravitational path. This theory reframes the search for extraterrestrial intelligence. We may not be looking for living beings, but for their silent, patient, and utterly inexorable robotic ambassadors, who began their journey when the universe was young and will continue their work long after our own star has faded to darkness. What if the ultimate form of travel required leaving your body behind entirely? The seventh theory proposes that the universe's first explorers transcended their biological origins, uploading their very consciousness into a digital or energy-based form. These post-biological beings would no longer be constrained by flesh, bone, or a limited lifespan. The crushing emptiness and million-year voyages that deter biological life would become trivial to them. They could reduce their essence to pure information, a stream of data representing every memory, thought, and facet of their identity. This data could then be transmitted across the cosmos at the speed of light, a ghostly signal riding on laser beams or radio waves. Upon reaching a suitable receiver, perhaps a sophisticated robotic body or a virtual reality waiting on the other side, their consciousness would be reconstructed and resumed, as if waking from a brief nap after a journey of millions of years. The travelers themselves would not experience the passage of time, only the instantaneous transition from one point in the universe to another, from one vessel to the next. Alternatively, they might choose a different path, storing their digitized minds on incredibly durable, microscopic probes no larger than a grain of sand. These tiny arcs, shielded from radiation and the ravages of time, could drift between galaxies for eons, powered by starlight, only activating when they finally encounter a star system with the right conditions to resurrect their passengers. For such beings, the concept of a spaceship is obsolete. Their bodies are temporary, interchangeable hardware, while their minds are the eternal, priceless software. This solves every major problem of intergalactic travel in one profound leap. There is no need for life support, no fear of cosmic radiation, no generational conflict aboard a ship, and no philosophical dread about the journey's length. They have achieved a form of immortality, becoming citizens of the cosmos itself. How would we ever detect such ephemeral explorers? We would not be looking for ships, but for anomalies in the data streams of the universe, a burst of complex information with a pattern that screams of artificial design, originating from beyond our galaxy. Or perhaps we might one day find one of their silent, dormant probes, a speck of dust hiding a universe of thought, waiting patiently in the void for its moment to awaken. The cosmos might already be threaded with highways we cannot see. This eighth theory proposes that the universe is naturally woven with a network of stable, traversable wormholes, cosmic shortcuts that form at specific gravitational sweet spots. These would not be the engineered tunnels of an advanced civilization, but natural features of spacetime, as inherent to the cosmos as stars and black holes. The first travelers, then, were not master engineers who bent the laws of physics, but intrepid explorers who learned to read the universe's hidden map. They discovered these portals, perhaps located at the delicate Lagrange points between binary stars or at the swirling junctions of galactic magnetic fields, and used them to hop between galaxies as easily as we might step through a door. These natural stargates would be the ultimate prize for any spacefaring culture, turning an impossible million-year voyage into a journey that might take mere moments. But how could we, from our limited vantage point, ever hope to detect such a structure? The most promising method lies in the subtle warping of light. A stable wormhole, while invisible itself, would act as a powerful gravitational lens. Our telescopes might observe a distant galaxy or quasar that appears strangely duplicated, its light bent around the hidden throat of the wormhole in a way that is distinct from the lensing caused by a black hole or a dark matter halo. The pattern would be unique, a telltale signature of a gateway. Another clue could come from the high-energy particles that constantly rain down on us from space. A wormhole could act as a cosmic particle accelerator, funneling radiation from one part of the universe to another. If we were to detect a source of ultra-high energy cosmic rays that seems to have no originating object pouring out from an apparently empty patch of sky between galaxies, it could be a beam of radiation that has traveled through one of these natural tunnels. Finding such a network would revolutionize our understanding of reality. It would mean the universe is not a vast, empty desert, but a connected web, filled with doors waiting to be opened by those who know where to look. Perhaps the ultimate ship requires no engine, no probe, and no body. It requires only a thought. This ninth theory ventures into one of the most profound and speculative ideas, that consciousness itself is not a product of the universe, but one of its foundational ingredients. This concept is known as panpsychism. It posits that some form of basic consciousness or experience is present in all things, from a human being to an electron. In such a universe, a civilization that fully mastered its own mind could learn to converse with this cosmic consciousness, using thought alone to reshape the fabric of reality. For these beings, intergalactic travel would not be an engineering problem, but a spiritual and mental discipline. They would not build a starship, they would become the starship. Imagine a collective of minds, a psychic network so advanced and unified that they could project their shared awareness across the void. Their journey would be a form of deep, cosmic meditation, a focused intention so powerful it could temporarily untether their consciousness from its physical anchor and relocate it to a distant point in space. They might perceive a target galaxy not as a destination, but as a concept, a feeling, a point of light in the mental map of the cosmos, and then simply will themselves to be there. What would this look like from the outside? Their physical bodies might remain behind, preserved in a state of suspended animation, while their essential self, their conscious experience, travels at the speed of thought. They would not be moving through space, but through a deeper layer of existence where distance is an illusion. The evidence of such travel would be nearly impossible for our instruments to detect, as it leaves no physical signature. We might only infer it from ancient legends or corrupted data streams speaking of beings who walked among the stars as ghosts, or from anomalous psychic phenomena reported near certain celestial objects. This theory challenges everything we believe about exploration. It suggests that the final frontier is not space, but the untapped potential of the mind itself, and that the first travelers may have left no ruins or radio signals because their greatest technology was the power of their own collective thought. Time itself could have been the ultimate fuel for the first pioneers, a civilization determined to send living, breathing explorers to another galaxy might have embraced the universe's own strange clockwork, using the predictable slowing of time at high velocities to cheat the eons. This is the time dilation survival strategy, a direct application of Einstein's special relativity. The principle is both simple and mind-bending. As a spacecraft approaches the speed of light, time for everyone and everything on board begins to flow more slowly relative to the outside universe. The ship does not just feel like it is moving fast, the very fabric of causality warps around it. For the crew, a heartbeat, a thought, a single day would proceed as normal. But back on their homeworld and across the entire cosmos, millions of years would flash by in the blink of an eye. A journey to the Andromeda Galaxy, which lies 2.5 million light-years away, would not take the crew 2.5 million years. From their perspective, tucked inside their relativistic bubble, the trip could be completed within a single human lifetime. They would accelerate to 99.9% of light speed, watch the constellations ahead shift into unrecognizable blurs of blue, and then, after what felt to them like a few decades, decelerate to arrive in a new galaxy. They would step out, biologically only a few years older, into a universe that had aged millennia. The engineering challenges, of course, are almost insurmountable. The energy required to push a massive ship to such a velocity is beyond staggering, likely requiring the total conversion of multiple Jupiter-sized planets into pure energy. Then there is the hazard of interstellar dust. At these speeds, a single hydrogen atom would hit the ship's hull with the force of a particle accelerator beam, and a grain of dust would strike with the energy of a nuclear bomb. The vessel would need a formidable shield, perhaps a kilometers-thick slab of advanced composite or a powerful electromagnetic field running continuously for the entire journey, deflecting this deadly cosmic sandblast. But for a crew that succeeded, the psychological impact would be profound. They would be true time travelers, launching themselves into the far future with every passing second. Their mission would be one of absolute, irrevocable commitment. Everyone they ever knew, their entire civilization, would be dust and legend by the time they reached their destination. They would be ghosts from a forgotten age, arriving in a new galaxy with no way to ever return home. They would not be exploring space, but leaping through time, carrying the memory of their world into a future it would never see. Some pathways may have been woven into the cosmos at its very birth. The 11th theory suggests the first travelers found their highways in cosmic strings, filaments of pure energy thinner than a proton but stretching across the entire universe. These are not mere strings in space, they are flaws in the fabric of spacetime itself, relics from the universe's first chaotic moments after the Big Bang. Imagine them as cosmic cracks under immense tension and possessing a density so incredible that a single inch of a cosmic string could weigh more than a mountain range. Their gravitational influence is staggering, warping the space around them into a kind of funnel or trough. A sufficiently advanced civilization would not need to build an engine to cross the galaxy. They could simply latch onto one of these primordial threads. The concept is akin to surfing. A ship would approach the cosmic string, using its immense gravity not to be pulled in and crushed, but to create a slingshot effect, accelerating to a significant fraction of the speed of light as it rides the gravitational wave coursing along the string's length. This would be a far more efficient and powerful method than any conventional propulsion, a free ride on the universe's own infrastructure. The true potential, however, lies in the string's connectivity. Some theories suggest these strings could form vast, looping networks, perhaps even connecting different regions of space that are otherwise impossibly far apart. A traveler surfing one string might find a junction where it intersects with another, allowing them to switch tracks and be hurled toward an entirely different galactic destination. The journey would be perilous. The space around a cosmic string would be a maelstrom of intense radiation and violent gravitational tides. Any ship attempting this would need shields far beyond our comprehension, capable of withstanding forces that would tear a planet apart. Yet for those who mastered this art, the universe would transform. The million-light-year gulf between galaxies would become a manageable commute along a pre-laid track. How could we ever detect evidence of such ancient surfers? We might look for the strings themselves. Astronomers search for them by looking for the unique gravitational lensing they would produce, a distinctive double image of a distant galaxy or quasar. But perhaps we should also look for signs of activity along these strings. An anomalous burst of energy, a flicker of unnatural light moving along the predicted path of a cosmic filament, could be the wake of a vessel that passed by 1 billion years ago, a ghostly echo of the first beings to ride the scars of creation. A warp drive is not science fiction, but a direct prediction of Einstein's own equations. The Alcubierre drive concept shows how a vessel could travel faster than light without breaking any physical laws by moving the space around it instead of pushing through it. Imagine the ship sitting within a bubble of normal spacetime. Ahead of the ship, space is compressed into a dense fold, pulling the destination closer. Behind it, space is expanded, pushing the point of origin far away. The ship itself rests motionless inside this warp bubble, a calm passenger on a wave of distorted reality. It does not accelerate, so the crew feels no crushing G-forces. The starship never moves through space faster than light. The space itself is moving, carrying the vessel along. This elegant solution sidesteps the relativistic nightmare of time dilation and infinite mass. But the obstacles are monumental. To create such a profound distortion of space-time would require an astronomical amount of energy, perhaps the equivalent of converting the mass of Jupiter into pure energy. Even more challenging is the need for a form of negative energy density, a hypothetical substance that creates a kind of gravitational repulsion to keep the warp bubble stable and open. This exotic matter is the key to preventing the bubble from collapsing the instant it forms. So how could the universe's first travelers have possibly achieved this? A Type 3 civilization commanding the power of entire stars might have found a way. They could have learned to generate the necessary negative energy by manipulating quantum fields on a cosmic scale, or by harvesting the bizarre physics of rotating black holes. Their solution might not have been a single, massive power source, but a deep understanding of resonance, using precisely tuned energies to create a stable warp field with far less power than we initially calculated. If they succeeded, their journeys would have left no conventional trail. We would not look for exhaust plumes or rocket flares. Instead, we might search for the ghostly imprints of their passage, subtle ripples in the fabric of spacetime itself, or a fleeting, lens-like distortion of a distant star's light as a warp bubble passed silently by eons ago on its way to a new galactic frontier. The universe we perceive might be a mere shadow of a far grander structure. A 13th theory suggests the first travelers did not cross the immense distances between galaxies, but simply stepped over them by accessing higher spatial dimensions. Our everyday reality is confined to 3 dimensions of space: length, width, and height. Yet, theoretical physics, particularly string theory, proposes the existence of additional compactified dimensions, a realm often called the bulk. In this higher dimensional space, the vast gulfs that separate galaxies in our three-dimensional universe could be mere inches apart. Think of our universe as a single sheet of paper. 2 points on opposite ends of the page are far from each other in the two-dimensional world of the paper itself. But if you fold the paper, those 2 points can touch. A being capable of moving through the third dimension, the space above the paper, could travel between them instantly, bypassing the long line entirely. The first travelers may have mastered this principle on a cosmic scale. Their great achievement was not building faster engines, but constructing vessels or technology capable of temporarily lifting their entire ship out of our three-dimensional plane and into the bulk. They would slip into this hyperspace, take a few short steps across a dimension we cannot perceive, and then re-emerge in a distant galaxy millions of light years away, all in the blink of an eye. What kind of engineering could possibly achieve such a feat? It would require a technology that manipulates gravity and spacetime at a fundamental level, perhaps by generating unimaginably powerful and focused gravitational fields to create a temporary bubble that pushes into the higher dimension. The energy required would be beyond comprehension, likely harnessing the power of multiple black holes in perfect concert. For the crew inside such a vessel, the journey would be utterly bizarre. As their ship transitions into the bulk, the familiar three-dimensional universe would appear to flatten and distort, perhaps becoming a shimmering membrane they could literally step across. The stars and galaxies would not be points of light in a void, but intricate patterns on a vast, curved surface. They would be travelers not just in space, but in the very geometry of reality itself. The evidence of their passage would be as elusive as the dimensions they navigated. We might one day detect a strange, instantaneous flicker, a star in one galaxy seeming to wink out for a nanosecond while another, impossibly far away, shows an identical, simultaneous flicker, a ghostly signature of something passing between them through a door we cannot see. A journey across the void might not need an engine, but a profound biological patience. This 14th theory proposes that the universe's first travelers were not masters of physics, but masters of life itself, a species that evolved to endure the ultimate voyage through sheer biological fortitude. Their ships were not made of metal, but of their own bodies, transformed into durable, seed-like vessels. These biological arcs would be the ultimate adaptation, a living capsule designed to protect its dormant passenger through millions of years of silent, sunless travel. Their metabolism would slow to an imperceptible trickle, a state of suspended animation so deep that it borders on non-existence, where a single heartbeat might span centuries. Encased within a shell of incredibly resilient organic material, perhaps layered with radiation-absorbing compounds and self-repairing tissues, they would simply drift, carried by the initial momentum of their launch and the gentle, inexorable tug of galactic gravity. They would be cosmic nomads in the truest sense, requiring no fuel, no complex machinery, just the ability to sleep for eons. Imagine such a vessel, indistinguishable from a small, dark asteroid to any distant observer. Its outer shell, pitted and scarred by micrometeoroid impacts over millennia, would hide a perfectly preserved, dreaming intelligence within. The journey would be powered by the most basic force in the universe, momentum, a gentle coast across an ocean of nothing. Their entire civilization might have been built around this biological imperative, a culture that saw such epic voyages not as a technological challenge, but as a natural, sacred phase of life, a great sleep between the stars. How would they ever wake up? Their internal clock could be tied to a specific gravitational cue, perhaps awakening only when their vessel was captured by a star's gravity well, or when they detected the complex chemical signature of a life-bearing world. They would arrive in a new galaxy not as conquerors but as seeds germinating after a million-year winter. The evidence for such travelers would be incredibly difficult to find, but not impossible. Our asteroid surveys might one day identify a strange object on a hyperbolic orbit, one that originated from outside our galaxy, with a density and composition that does not match any known type of rock or ice. It would be a biological ship still dreaming its long dream, silently passing through our celestial neighborhood as it has through so many others, a living fossil from a galaxy far, far away. The silence of a million-year journey was not a problem they needed to solve, but a condition they accepted from the very beginning. This 15th theory envisions a civilization that chose the most direct and violent method of all, a galactic-scale mass driver. Think of it as the ultimate slingshot, an electromagnetic railgun of such staggering proportions that it could accelerate a vessel to a significant fraction of light speed in a single, shattering push. The scale of this engineering project is almost beyond comprehension. The launch track itself would have to be thousands of miles long, perhaps built in the empty space between stars, using the entire magnetic field of a planet or even a star to power its immense coils. The energy required for a single launch would be astronomical, potentially consuming the total power output of a civilization for centuries, all focused into one fleeting, explosive moment. The payload, whether a rugged, uncrewed probe or a brave crew encased in a protective cocoon, would experience acceleration forces that would crush any conventional structure to dust. Only a vessel engineered at the molecular level, with integrity fields and inertial dampeners we can barely dream of, could possibly survive the initial jolt. This was not a method for the timid. It was a statement of ultimate commitment, a way to fire a message in a bottle across the cosmic ocean with no hope of return and no way to slow down at the other end. The first intergalactic traveler, then, might not have been a majestic starship but a hyper-dense projectile, a silent bullet of pure information and purpose hurtling through the void. Its mission would be simple: survive the launch, endure the eons of travel, and then, upon entering the target galaxy, awaken its systems for a brief, intensive period of observation before its momentum carried it out the other side and into the eternal dark. What would such an object look like to us? If one ever passed through our own Milky Way, it would be a tiny, impossibly fast-moving speck, a blur of radiation and reflected starlight on a trajectory that clearly originated from beyond our galactic borders. It would be a fossil of a single, monumental act, a testament to a civilization that chose to reach for the next island of stars not with a gentle push but with a cosmic shout. The heart of every galaxy holds a monster, a gravitational anchor so powerful it could fling a starship across the cosmos. This 16th theory proposes the first travelers used these supermassive black holes not as obstacles but as the ultimate propulsion system. They would have treated the universe as a vast pinball machine, where each galactic core was a bumper waiting to hurl them toward the next. The maneuver is a gravity assist on a truly cosmic scale. A vessel would dive toward the black hole's event horizon, riding the steep curvature of spacetime like a surfer catching a wave. It would not fall in, but whip around the abyss in a tight, parabolic arc, stealing a fraction of the black hole's orbital momentum and being flung away at a velocity far greater than it arrived with. A single such slingshot could provide a tremendous boost, but the true genius lies in the chain. A civilization would plot a course linking multiple galaxies, a route where the exit trajectory from one black hole perfectly aligns with the approach to the next, millions of light years away. This would be a dance of celestial mechanics requiring godlike precision, where a miscalculation of a single mile per hour at the first slingshot would mean missing the next galactic core by thousands of light years. The journey itself would be a lesson in patience and faith, a multi-million-year voyage where the crew would spend eons in the dark between galaxies, only for brief, terrifying moments of incredible acceleration as they skimmed past each gravitational giant. The view during one of these close passes would be both breathtaking and terrifying. The black hole itself would be an invisible sphere of absolute black, surrounded by a swirling, incandescent accretion disk of superheated gas and dust, warping the light of the entire galactic core into a shimmering halo around it. The ship would be bathed in the intense glare of radiation, its shields straining against the cosmic fury, all while the fabric of spacetime itself twisted and pulled at the vessel. For a civilization that mastered this, the universe would become a connected network of gravitational wells, and their greatest achievement would not be the ship they built, but the perfect, timeless map they learned to follow. Our reality might not be the final layer of existence. This 17th theory explores the startling possibility that the universe is a sophisticated simulation, an immense computational construct running on a substrate of reality we cannot perceive. The first travelers, then, were not beings who built ships, but entities who achieved the ultimate awakening, realizing they were inside a cosmic computer. Their method of intergalactic travel was not physics, but programming. They learned to hack the source code of the universe itself. Imagine discovering that the laws of nature are not immutable decrees, but lines of software, a cosmic operating system with its own syntax and logic. For these awakened travelers, crossing millions of light years would not require moving through simulated space. It would be a simple matter of editing their own location parameters in the universal coordinate system. They could change their X, Y, and Z values in the master code, effectively teleporting from one galactic address to another in an instant, leaving no physical trace of their journey. How could a civilization possibly achieve such a feat? They would need to find a backdoor into the system, a vulnerability or an unpatched exploit in the fabric of reality. Perhaps they discovered this through advanced mathematics, identifying patterns and constants that were a little too perfect, a little too clean, revealing the underlying algorithmic structure of everything. Or maybe they developed a technology that could directly interact with the quantum foam, the pixelated base layer of spacetime, interpreting its fluctuations not as random noise but as executable code. Their journey would be the ultimate act of hacking. They wouldn't pilot a starship, they would write a command. The evidence of their travel would be nearly impossible for us to detect, as it would violate the very laws of physics we take for granted. We might only see the aftermath, an anomaly that makes no scientific sense, like a star that appears to wink out in one galaxy and simultaneously ignite in another, or a planet with a biological history that seems to have been inserted fully formed with no preceding evolutionary record. This theory reframes the entire quest for intergalactic travel. The final frontier is not space, but the very nature of our existence, and the first pioneers may have left by not traveling at all, but by simply rewriting their place in the script. The 18th theory dissolves the line between vessel and voyager entirely. What if the first travelers did not build a ship but found one, a partner already adapted to the void? This idea proposes a symbiotic relationship between a biological species and a cosmic entity, a life form native to the emptiness between galaxies. Imagine a being not of rock and flesh, but of swirling ionized gas and coherent magnetic fields, a sentient nebula. This vast, placid intelligence would naturally drift on the currents of dark energy and galactic gravity, its lifespan measured in billions of years, its consciousness utterly alien to our own. For a civilization facing the impossible challenge of intergalactic travel, encountering such an entity would be the ultimate opportunity. They would not need to engineer a warp drive or a generation ship. They would need to learn to communicate. A pact could be forged. The biological species, with its nimble, tool-using intelligence and its thirst for exploration, would offer something the entity lacked: detailed knowledge of planetary systems, the structure of stars, or perhaps even the abstract concepts of art and mathematics. In return, the entity would become their vessel. It would envelop their cities or their arcs within its protective electromagnetic embrace, shielding them from cosmic radiation and micrometeoroids. It would then use its own innate understanding of spacetime to navigate the void, its massive form riding cosmic winds that no manufactured engine could ever harness. The civilization would live inside this living ship, their world defined by shimmering curtains of light and the gentle, constant hum of the entity's magnetic heart. They would travel as part of a greater whole, a merged being exploring the cosmos together. The journey's timescale, millions of years, would be a mere season in the life of their cosmic partner. Evidence of such a symbiosis would be fleeting and strange. Ancient astronomical records might speak of a nebula that moved with unnatural purpose, its light spectra showing complex, structured patterns unlike any natural cloud of gas. Or our telescopes might one day observe a similar entity entering our galactic halo, and within its glowing depths detect the faint, organized radio whispers of a civilization that long ago learned to call the void its home. A starfaring civilization might have learned to cheat the very concept of distance by treating the cosmos as a quantum barrier. This 19th theory explores the staggering possibility of quantum tunneling on a macroscopic scale. In the subatomic world, particles like electrons do not always bounce off energy barriers. There is a small but real probability they can simply appear on the other side, as if they passed through an insurmountable wall without ever actually crossing it. This is not science fiction, it is a fundamental, proven property of quantum mechanics. Now, imagine a Type 3 civilization that learned to apply this principle to an entire starship. They would not see the 2.5 million light-year void to the Andromeda Galaxy as an empty expanse to be crossed. Instead, they would view it as a single, immense energy barrier, a wall of probability. Their technology would not propel the ship through that space. It would momentarily synchronize the entire vessel's quantum wave function, effectively turning the starship into a single, macroscopic quantum particle. Then, with a surge of unimaginable energy, they would momentarily suppress the probability of the ship being in its current location, while simultaneously boosting the infinitesimal probability of it being in the target galaxy to near certainty. From an outside perspective, the vessel would not accelerate or streak away. It would simply vanish from one point in space and instantaneously reappear in another, having never traveled the distance in between. It would be the ultimate teleportation. The engineering challenges, of course, are beyond colossal. The energy required to manipulate the quantum state of something as complex and massive as a starship is incalculable, likely demanding the focused power of multiple neutron stars. The precision needed is even more daunting, as any error in the quantum calculation could result in the ship materializing inside a star or scattered as random particles across the void. For a crew that attempted this, the journey would be both instantaneous and non-existent. There would be no sensation of movement, no passage of time. One moment they are orbiting their home star, and the next they are surrounded by the unfamiliar constellations of a new galaxy. The evidence of such a transit would be as ghostly as the phenomenon itself. We might one day detect a brief, powerful flash of Cherenkov radiation in the empty space between galaxies, the telltale sign of a massive object briefly interacting with the quantum vacuum during its impossible jump. A fading echo of the first travelers who learned not to fly, but to simply step through the walls of reality. Some journeys begin with an act of cosmic arson. A civilization determined to escape its galactic cradle might have turned its own sun into a bomb. This 20th theory presents the most audacious and violent method of all, the leveraged supernova. Imagine a culture so committed to reaching another galaxy that they choose to obliterate their home system as the price of departure. They would not build a traditional engine. Instead, they would engineer the death of their star, inducing a supernova or an even more powerful hypernova. The goal is not destruction for its own sake, but propulsion. By positioning their vessel at a precise, calculated distance and orientation from the star, they could harness the unimaginable force of the explosion. The ship would act like a surfer waiting for the perfect wave, but this wave is a sphere of incandescent plasma and a shockwave of pure energy expanding at a fraction of the speed of light. The vessel's shield facing the detonation would be an astronomical marvel, a perfect energy reflector designed to absorb the initial flash and then ride the subsequent physical shockwave. The kick would be instantaneous and brutal, a single, shattering push that could accelerate the arc to a significant fraction of light speed in a matter of minutes. This is a one-way ticket with no possibility of return, a gamble where failure means instant vaporization. The timing and positioning would have to be flawless. A calculation off by a fraction of a degree would see the ship torn apart or sent spiraling off into the intergalactic void on a useless trajectory. Why would any culture attempt such a thing? Perhaps they were fleeing an unstoppable galactic threat, sacrificing their world to ensure their species' survival elsewhere. Or maybe it was the ultimate expression of their philosophy, a belief that to truly reach for the stars, one must be willing to destroy a star. The evidence of such a desperate act would linger for millennia. Astronomers might one day find a young, unusually shaped supernova remnant, a bubble of expanding gas with a strange, linear feature punched through one side, the ghostly wake of a vessel that turned a stellar death cry into its own birth scream, catapulting itself out of the galaxy on a pillar of fire. The cosmos is held together by an invisible skeleton. This 21st theory suggests the first travelers learned to climb it. We have long known that the visible stars and gas in a galaxy are like the lights on a Christmas tree, while the tree itself, the vast majority of its mass, is made of something we cannot see, dark matter. This mysterious substance forms an immense spherical halo around every galaxy, a ghostly structure that governs the motions of stars with its silent gravitational pull. A civilization that could perceive and interact with this dark scaffolding would have found the ultimate road. Their ships would not have pushed against empty space, but against the dark matter itself. Imagine a vessel equipped not with rockets, but with a device that creates a localized, powerful gravitational field, one that can get a purchase on the invisible dark matter particles flowing through and around the galaxy. It would be like placing grappling hooks into an unseen rock face. By selectively pulling against this dark matter medium, the ship could propel itself forward, climbing hand over hand through the invisible architecture of the cosmos. This form of propulsion would be incredibly efficient, a continuous push against a medium that is everywhere, requiring no onboard fuel in the conventional sense. The energy would be drawn from the ship's manipulation of gravity itself, a technology that taps into the fundamental force binding the universe together. How could we ever detect the wake of such a vessel? We might look for strange, linear disturbances in the rotation curves of distant galaxies, a subtle warping in the way stars move that suggests something massive and unseen passed through, plowing through the dark matter halo and leaving a temporary ripple in its gravitational field. These travelers would have been masters of the unseen, their journeys silent and effortless, moving not through the empty void, but along the crowded, invisible highways that truly structure our universe. But to touch the engine of reality, you must first shrink your perspective to the very smallest of scales. At the foundation of everything, space is not smooth and empty. It is a seething, turbulent foam, a constant dance of creation and annihilation where pairs of virtual particles, one matter and one antimatter, flicker into existence for an unimaginably brief moment before colliding and vanishing back into the energy from which they came. This quantum foam is the lowest level of existence, governed by the Planck scale, a realm where our classical laws of physics break down and distance itself becomes a fuzzy, uncertain concept. The 22nd theory posits that the first travelers built an engine that could push against this seething nothingness. A Planck-scale drive would not burn fuel or expel plasma. Instead, it would create a fundamental asymmetry in the quantum vacuum. Imagine a perfectly mirrored chamber. Normally, the constant pressure from these virtual particles pushing on the walls would be equal in all directions, cancelling each other out. But what if you could manipulate one wall, perhaps with an impossibly powerful and fluctuating electromagnetic field? so that more virtual particles were repelled from its inner surface than from the opposite wall. For a fleeting instant, the push from one side would be greater than the push from the other. The chamber would experience a net force, a tiny, infinitesimal thrust from nothing. This is the principle of a reactionless drive, a concept that seems to defy Newton's third law of motion, that for every action there is an equal and opposite reaction. The trick is that the reaction is not against the ship's own propellant, but against the very fabric of space-time. The thrust from a single such event would be vanishingly small, far less than the weight of a single snowflake. But a civilization that mastered this technology could scale it up, creating vast arrays of these quantum thrusters operating in perfect, rhythmic unison. The key is continuous, unending acceleration. Unlike a chemical rocket that burns its fuel in a few violent minutes, a quantum vacuum drive could push gently, ceaselessly for millions of years. It would be an engine with no moving parts and no need for fuel tanks, powered by the underlying energy of the universe itself. A ship equipped with such a drive would slowly, inexorably build up speed, its velocity climbing year after year, century after century. After 10,000 years, it might be traveling at a tenth the speed of light. After 100,000 years, it could be approaching 99%. The journey to another galaxy would still be an epic undertaking spanning eons, but it would be a voyage of constant, gentle progress, a silent glide powered by the hum of quantum static. The crew, perhaps in suspended animation or existing as digital minds, would be unaware of the millennia slipping by, their ship a self-contained world steadily climbing the velocity ladder on a tide of manipulated nothingness. The evidence of such a journey would be as subtle as the phenomenon that powers it. We might never see the ship itself, but we could potentially detect the cumulative effect of its passage, a faint, lingering distortion in the quantum vacuum along its historic trajectory, a ghostly wake in the structure of reality left by the first beings who learned to sail on the foam of spacetime. The very stars could be connected by a living web. This 23rd theory proposes a biological universe, one laced with a galactic mycelium network. Just as vast fungal networks beneath a forest floor connect trees in a symbiotic exchange of nutrients and information, a similar, unimaginably large organic structure might weave through subspace itself, linking entire galaxies with living filaments. These would not be physical threads you could touch, but conduits of consciousness and biological energy, existing in a dimension adjacent to our own. A species profoundly in tune with this natural system, perhaps one that evolved a powerful psychic empathy or a unique biological resonance, would not need to build ships or engines. They would learn to tap into the network itself. For them, travel would be a process of attunement and translocation. They might enter a meditative state, their collective consciousness harmonizing with the frequency of a specific mycelial strand, and then simply step into the network's flow. It would be less like piloting a vessel and more like entering a living river, a current of shared sentience that carries them across the light years in an instant. The experience would be as much a spiritual journey as a physical one, immersing the traveler in the thoughts and memories flowing through the cosmic network itself. Evidence of such a system would be nearly impossible to detect with conventional instruments, as it operates on a biological and psychic plane. We might only find hints in ancient myths or corrupted data streams speaking of a root system of the stars, or in anomalous, organic-looking energy patterns detected in the deep void between galaxies, patterns that pulse with a rhythm that feels suspiciously like life. This theory suggests that the universe's greatest secret may not be a law of physics, but a form of biology so vast and interconnected that it forms the true nervous system of the cosmos. These space-time tsunamis offer a ride like no other. When two supermassive black holes spiral toward a cataclysmic merger, they do not collide quietly. They churn the cosmos, sending out ripples in the fabric of spacetime itself, distortions that travel at the speed of light and stretch and compress everything in their path. We have only recently learned to detect the faintest echo of these waves from stellar mass black holes. Now, envision a civilization that could perceive them with godlike clarity, predicting a galactic collision millions of years before the final, violent embrace. Their method of travel would be the ultimate act of cosmic timing. They would not fight the void but become one with its rhythm. Imagine a vessel designed not for propulsion but for resonance. Its hull would be a perfect gravitational wave antenna, tuned to the specific frequency of an oncoming spacetime ripple. As the wave front approaches, the ship would lock onto its oscillating geometry. The effect would be like a surfboard catching a perfect, endless wave. The ship would be carried forward not by thrust, but by the wave's own momentum, its own stretching and compressing of space acting as an engine. It would be carried along, surfing the very distortions that define reality. The journey would be a wild, chaotic ride. The crew would experience space itself breathing around them, with distances momentarily shrinking and expanding in a rhythmic, nauseating dance. There would be no sense of smooth acceleration, only the visceral feeling of being part of the wave, a speck on a tide of pure gravity. The energy harvested from this cosmic surf would be immense, a free ride on the most violent events in the universe. But the precision required is almost beyond comprehension. Miscalculating the wave's amplitude or angle of approach by even a fraction would result in the vessel being torn apart, its atoms scattered across the intergalactic medium by forces that can warp entire galaxies. For those who mastered it, the universe would become a symphony of gravitational currents, and their greatest explorers would be those who learned to dance to its most powerful beats. A conscious mind might form from the chaos of empty space, a fleeting thought in the cosmic dark. This is the startling premise of the Boltzmann brain, a self-aware entity that spontaneously assembles from random quantum fluctuations in the void. In this bizarre scenario, the universe's first intergalactic traveler did not build a ship or traverse a wormhole. It simply popped into existence, complete with a fully formed memory of a journey that never happened. Imagine a brain or a coherent pattern of consciousness coalescing from the quantum foam in the emptiness between galaxies. By sheer, unimaginable chance, this spontaneously generated mind contains what feels like a lifetime of memories, including the vivid experience of traveling from a distant galaxy called Andromeda. It believes with every fiber of its being that it embarked on a monumental voyage. It can recall the engineering of its vessel, the long eons of star flight, and the triumphant arrival in a new galactic home. Yet none of it is real. The memory is a fantasy, an incredibly detailed and convincing illusion baked into its consciousness at the moment of its creation. The probability of such a specific, complex fluctuation occurring is astronomically low, so small it is effectively zero for all practical purposes. But in an infinite or near-infinite universe over an infinite span of time, even events of vanishingly small probability are not just possible, they are inevitable. Given enough time and enough space, anything that can happen will happen, including the spontaneous formation of a mind that mistakenly believes it is an explorer. This theory turns the very nature of evidence and experience on its head. How could we or any traveler ever truly trust our own memories? If a Boltzmann brain can feel just as real and have just as rich an internal life as a brain that evolved biologically, then the first pioneer of the cosmos might not be an ancient civilization at all, but a ghost of probability, a cosmic accident that thought itself into being and for a fleeting moment believed it had conquered the void. A hidden particle could unlock the cosmos. Magnetic monopoles are one of physics' great hypothetical treasures, a magnet with only a single pole, either a north without a south or a south without a north. Every magnet we have ever found is a dipole with two inseparable poles, but the mathematics of the universe suggests these solitary poles could exist, and if they do, they would be a source of power on an almost mythical scale. The energy released from a single monopole could dwarf that of a nuclear reactor. Now, imagine a civilization that did not just theorize about these particles, but learn to find them, perhaps in the high-energy aftermath of the Big Bang, or created in their own particle colliders encircling entire stars. They would have harvested the universe's ultimate power source. Their propulsion system would be an engine of profound elegance. Instead of carrying immense tanks of fuel, their vessel would be equipped with a reservoir of these monopoles. By directing the intense magnetic fields emanating from them, the ship could push against the faint but pervasive magnetic fields that are woven through the emptiness of intergalactic space. It is a concept akin to sailing, but on a cosmic ocean where the wind is an invisible, omnipresent magnetic breeze. This would provide a constant, unending thrust. The ship would accelerate slowly at first, then faster and faster, building momentum over centuries and millennia without ever running out of push. There would be no violent explosion at launch, only the silent, relentless hum of a field interaction that propels the vessel forward on a tide of magnetic force. The journey would be one of supreme patience and power, a testament to a culture that learned to harvest the fundamental building blocks of reality to catch a ride on the magnetic currents of the void itself. A civilization's final act could be to scatter its own blueprint into the cosmos. This theory reframes the ancient idea of panspermia, not as a random accident, but as the most fundamental form of deliberate intergalactic travel. A species staring into the abyss of its own extinction might choose not to send a ship, but to encode the very essence of who they were into microscopic, indestructible capsules. Their entire genetic library, the sum of their biological identity, along with the core patterns of their culture and knowledge, could be stored within the robust structure of custom-designed bacteria or complex organic molecules. These would not be simple spores, but sophisticated data archives, engineered to survive the absolute zero temperatures, intense radiation, and million-year timescales of an intergalactic voyage. Their vessel would be the most basic of all, a lifeless rock. They would use cosmic events, perhaps a precisely calculated asteroid impact or the gravitational slingshot of a passing star, to launch these seeded stones out of their galaxy and on a trajectory toward a distant, fertile spiral. The journey itself is one of pure, blind faith. There are no sensors, no course corrections, only the silent, patient drift of a rock tumbling through the void, its precious cargo dormant within. The intended recipients of this message are not other civilizations, but the universe itself. The hope is that one day, after an unimaginable expanse of time, one of these stones would be captured by the gravity of a young, life-friendly world. It would crash into its new home, and in the warm, chemical-rich oceans, the capsules would dissolve, releasing their encoded instructions. This would not be the arrival of an explorer, but the planting of a seed. The legacy of that ancient civilization would not be a ruined city or a radio signal, but the very life that then evolves on that planet. Their descendants would not be their children in a biological sense, but the trees, the creatures, and the intelligent beings that eventually emerge, all carrying a hidden, fragmentary inheritance from a galaxy far away. We could be the unintended result of such a desperate, final journey, our own DNA perhaps interlaced with the faded signature of a culture that died out long before our sun was even born. Our reality may be nothing more than a magnificent illusion, a three-dimensional image projected from a distant, two-dimensional surface. This is the holographic principle, and it could have been the ultimate key to intergalactic travel. The theory proposes that all the information describing our universe, every star, every planet, and every one of us, is actually encoded on a vast, cold boundary that may surround us at an unimaginable distance. We are the projection, the three-dimensional movie playing out from a two-dimensional cosmic film reel. The first travelers, then, were not masters of space, but masters of information. They learned to read this underlying code, to understand that the universe operates like a computer, and they discovered the ultimate cheat code. They realized they did not need to travel across the immense void to another galaxy. They simply needed to edit their own location coordinates in the universal source code. Imagine a character in a video game realizing the world is just data. Instead of walking from one side of the map to the other, the character could simply change its X and Y coordinates in the game's memory, instantly appearing in a new location. For these pioneers, the journey was a matter of accessing the universe's projector and rewriting the script. Their physical form would dissolve here, not into nothingness but into pure information, and then be instantly reassembled there in a different galaxy, as the projection simply resumed from a new point on the cosmic screen. The energy required for such a feat would be beyond comprehension, perhaps drawing power from the spin of a supermassive black hole to make the necessary edits to reality's firmware. The evidence of their passage would be the most ghostly of all, a momentary glitch in the cosmic projection, a star that flickers in one galaxy as another simultaneously brightens, a fleeting signature of a consciousness that learned it was living in a hologram and decided to change the channel. A crack in the newborn universe might still be open for travel. In its first fleeting fraction of a second, our cosmos underwent a period of unimaginably rapid expansion called inflation, ballooning from smaller than an atom to a vast volume faster than light itself. That violent birth left scars, and one of the most profound theories suggests that not all of that inflationary energy dissipated. Bubbles of that primordial, hyper-expanding spacetime could have been pinched off, forming stable cosmic pockets that still drift through the modern universe like ghostly relics. These would not be regions of space as we know it, but preserved fragments of the universe's most explosive moment, where the fundamental laws of physics might operate differently. A civilization that learned to detect and enter one of these inflationary bubbles would have found the ultimate vessel. They would not need to build an engine to cross the void. They would simply step inside a fragment of the Big Bang's aftermath and let the universe's own creation energy carry them. The experience would be beyond anything we can conceive. Once inside the bubble, the space around their ship would not simply move, it would erupt. The destination galaxy, millions of light years away, would rush toward them not as a distant point of light, but as a rapidly expanding wall of reality, the bubble's boundary hurtling outward at speeds that defy causality. For the travelers, the journey might feel instantaneous, a single, breathtaking lurch as the cosmos rearranged itself around them. They would be riding a wave from the dawn of time, a surfer on the very first shockwave of existence. How could anyone possibly navigate such a thing? The key would lie in prediction and timing. They would need to calculate the trajectory of these drifting bubbles with godlike precision, knowing exactly when and where one would intersect with their location and their desired destination. A miscalculation would be catastrophic, sending them hurtling into the endless void between galactic superclusters with no way to stop. The evidence of such a journey would be written in the sky, but in a language we are only just learning to read. Modern telescopes mapping the cosmic microwave background, the afterglow of the Big Bang, look for tiny temperature fluctuations. Perhaps one of those subtle anomalies is not a random density variation, but the faint, cooled imprint of an inflationary bubble's wake, a scar left on the oldest light in the universe by the passage of the first travelers, who learned to sail on the fading momentum of creation itself. The final theory unifies everything. It is the long-sought-after theory of everything, a single, elegant framework that explains gravity, electromagnetism, and the nuclear forces as different manifestations of one underlying principle. For the first travelers, the discovery of this ultimate theory was not just a scientific triumph, it was an awakening. They did not simply learn the laws of the universe, they learned the universe's source code. Their method of intergalactic travel became something we cannot yet even properly imagine, a fundamental reordering of reality that made the journey not a voyage but a simple change of state. Think of it like this: we see a locked door and we search for a key. They, possessing the unified theory, would understand that the door and the lock are an illusion. The separation between here and there is a condition of a limited perspective. With their complete knowledge, they could simply redefine their location within the cosmic framework. It would not be warping space or tunneling through it. It would be editing the coordinates of existence itself. The process would be seamless, almost effortless. There would be no roaring engines, no shimmering portals, no disorienting jump. One moment they are in their home galaxy, and the next they are in another, as naturally as you might step from one room into the next. The energy required would not be a monstrous draw from stars, but a precise, minimal application of force at the most fundamental level, like pressing the correct sequence on a cosmic keypad. For them, the million light-year gulf was not a distance to be crossed, but a parameter to be adjusted. This is the ultimate destination of physics, a point where science and what we might call magic become indistinguishable. The evidence of their travel would be the most profound silence of all, a universe that behaves exactly as predicted, yet occasionally produces phenomena that should be impossible, brief moments where the cosmic rules seem to bend without breaking, the faintest echo of a presence that learned to speak reality's native language and simply asked to be somewhere else. From the elegance of warp drives and wormholes to the audacity of cosmic surfers and digital beings, we have navigated 30 incredible visions of the universe's first intergalactic pioneers. Each theory is a testament to the boundless creativity of the human spirit, a different key attempting to unlock the same magnificent door. We stand at the precipice of this mystery without a final answer, and that is perhaps the most exciting part. The very act of asking these profound questions, of daring to sketch maps for territories we cannot yet see, is what propels science and imagination forward. It stretches the limits of what we believe is possible, challenging us to look past the familiar and into the great unknown. So we turn this final thought over to you. Which of these journeys captured your mind? Did the patient biological arc drifting for eons speak to you, or the instantaneous leap through a higher dimension? Perhaps the idea of a cosmic mycelium network, a living universe, felt the most true. Share your favorite theory in the comments below. We are truly curious to hear what you think. If you enjoyed this deep dive into the cosmos, please subscribe for more journeys to the edge of understanding, and always keep looking up.